Alright, so I'm going to briefly show how to use proof blocks. I have, I believe, all of them right here, including the G and the P, which stands for given and picture. Those two circular ones demonstrate what is provided right here. This is what's given, two different pieces of information. And this is also a given. The picture, it's provided. It tells us things about the triangles we're dealing with just by looking at it. Now, a lot of times students will think that there's more information than there actually is, but there are some reliable pieces of information shown in the picture. And those usually have to do with endpoints. Like you can see B, D are the same points on both triangles. So is E, just that kind of idea. Now, let's start. So we know we need to start with what's given, so we always start out with G. Make this a little bit smaller. And what is given? What is given is that A is congruent to angle C. So angle A is congruent to angle C. So this angle here is congruent to this angle here. Cool. And I'm going to write this so that we are considering the other vertices of the triangle. So, for example, angle C can be written as angle ECB, and angle A can be written as BAD. And the reason why I want to write it like this, although it's already a good practice, BAD, is because this is how these congruencies are outlined in our proof blocks. So you can see down here, for example, by the ASA, angle side angle postulate, we have angle blank 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 is congruent to angle blank blank blank. So that's why I'm writing it out, so you can see it and it'll fulfill that sort of pathway to the end of your proof. So we know this is given, and we're also given one other piece of information. We know that side length AB is congruent to side length BC. So AB is congruent to BC. Now I'd say it's good practice to, just like I did with the angles, show what is congruent in terms of side lengths. So separate these out, put them right here. Move them over a little bit, just so we can really see the congruencies. So this point would be D, this point would be B, this is A, this point here is E, this point is C, and this point again is B. So we know that BC, that's right here, maybe I'll do it in red, BC is congruent to AB. So now we have, just off the given, we have two angles that are congruent and two side lengths that are congruent. Now if you look at these blocks, right, this is what we want to end with. Triangle blank 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 is congruent to triangle blank blank blank. So based on the fact that we have a side and an angle that's congruent, I can sort of put side 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 away, right, because we're not going to be using an angle on side side side. But we need to figure out which of these is going to end it. Let's say put angle side angle here just to demonstrate what we're doing. This is our end goal. Over here on the left is what we started with. Now the P here is for what's provided in the picture. P stands for picture. So we should be able to, looking at this picture, determine some sort of congruencies that aren't stated as givens. So looking at this picture, we should be able to see, oh, angle B is the same for both. Right? It's the same exact angle. And that's because CBE, so CBE, is the same angle as ABD. They share the same points. They have the same, they all lie on the same line segments. So right here I can outline in my separate triangles. Angle B is congruent to angle B. Now, the reason we can say that is by the reflexive property. So I'm going to bring this up right next to P, picture. By the reflexive property, it just basically states like Mr. Black is Mr. Black. Just saying something is itself, essentially. So since angle B is the same as angle B is congruent to angle B. Again, though, I'm going to write this so that it follows this sort of structure so we can recognize it when we need to use it. So for this triangle here, the first one, I'll say angle EBC, is congruent to angle ABD. Cool. So now we have three different congruencies. Let's actually bring them all the way out to here. And we already have them in the proper order, and we have ASA out, which is good, because that's the one we're actually using, right? We have an angle, a side, and an angle that are congruent. You can see it here just like this. Angle, side, side, angle. So you have angle, side, angle. Cool, we've lined everything up, everything fits. Now we can end with saying what we were aiming for, to prove that triangle CBE is congruent to triangle ABD. Triangle CBE is congruent to triangle ABD. And that's all we need to do.